All right, so the other thing we want to look at is just graphing horizontal and vertical lines. Remember we talked about positive slopes and negative slopes. What's interesting with this is y equals to mx plus b is the representation of both of these. And what you'll see is that with diagonal lines, you have both the x and the y in there. But with the zero slope and the undefined slope, what we're going to see is that is only one of the variables. Now, with the undefined slope, remember, an undefined slope means that it's not a function. And remember, not being a function, f of x, means I can't say f of x equals something. And so for this one here, anytime it looks like this, it's a x equals to whatever the constant is. It could be 5, it could be 3. So if this was 3, then this would be x equals 3. And it basically means that every single point, my x would be 3 something. This could be 3, 1. This one could be 3, comma 3. This could be 3, negative 1. And it's just basically saying my x will always be 3. Because it's undefined, it cannot be written in an f of x equals or y equals format. And so keep that in mind as you will be challenged with that as you move on in different chapters. All right, and then similarly, because this is a zero slope, that means I won't have any m in there. And so it might just be y equals to the constant or the y-intercept, right? So whatever the y-intercept is, if it's a zero slope and I put y equals to negative 2, and this value here is negative 2, it just means that every point on this line is going to be negative 2 on the y-axis. And so let's just say this is negative 1. That's pretty high. Negative 4 and negative 2. Right? It just means that every point on that line is going to be negative 2 something. So like if I had this point and this was like 5, then this would be 5 as my x value and negative 2 as my y. So that line is just constant throughout, negative 2. And so it's basically the y-intercept. And zero slope means that just disappears, right? So good thing to know as it will help you further on. So keep that in mind. If you see x equals something, x equals to a number, it's a vertical line. And if you see y equals to a number, it's a horizontal line. Okay, so let's try this out. Graph y equals to 2. Well, y equals to 2 means that it's a horizontal line. It means it has a zero slope. And so y equals to 2 would be a line that passes through there parallel to, and that's pretty straight, parallel to the x-axis, right? And then x equals to negative 3. Well, what would that look like? Well, that means it's going to go through first the point negative 3, and it's going to be, because it has no slope, it's not even in function notation format, or its equivalent, which is y equals, it's a vertical or undefined slope, right? That means you only have the x value. So this one would be x equals negative 3, and the other one would be y equals to positive 2. So keep that in mind for whenever you have a horizontal or vertical line. All right, so one thing we want to do is see, we're just going to do one of these. This is the other two are going to be part of your homework. And let's see, let's do number 37. And so I'm going to match 37 to either A, B, or C. And then for homework, you could do 38 or 39, matching them. So for number 37, we want to match the graph using our understanding of standard form. All right, so if you were to set y equal to 0 here, it would basically disappear, and you have x equals negative 8. So basically you need to find a graph where x is at negative 8. Now notice this graph is going by 2's, this one's going by 1, and this one's going by 2's. So keep that in mind. So all of them have an x value of negative 8. So if we check this one, that's negative 1, negative 2, negative 3. So it can't be that one. All right, so we know it's not the very last one. Then we need to check to see if it's the second one. We know, once again, that x will be equal to negative 8 because, let me write it out. For my first one, remember you set y equal to 0. So for the x-intercept, x equals negative 8. So that's why I'm looking for negative 8. So this one's going by 2's, part B. So this is negative 2, negative 4, negative 6, negative 8. Now before we guess that, we just have to make sure the other one's not negative 8 as well. because they could have both -8 and then a different y. So it's always safe to check it. This is -2, -4, -6. So bam, we already know our answer. Number 37 matches with B. Okay, so for the other ones, do the same thing. You're going to find your x and y intercept. And just for verification's sake, so you can see how it works, if you were to find the y-intercept, that's going to be 0 subtract 4y equals to -8. And if we solve that, dividing both sides by -4, both sides by -4, we're going to get y equals to +2. And that's exactly what you see there. Oh, sorry, that's 4. What I'm talking about, that's exactly what you see here, because we said our answer is B. So we get our -8 and we get our +2. Right, so that's our answer, B. So 37 is B. So now you just have to decide between 38 and 39, which one goes with A, which one goes with C. Okay, this might be our last question, and let me just see. Yeah, that's our last question. So student tickets at a high school basketball game. This comes from number 63 in the book. Student tickets at a high school basketball game cost $2.50. Adults tickets cost $6 each. The ticket sales at the first game of the season totaled $7,000. Write a model that shows the numbers of students and adult tickets that have been sold. Now remember, this goes back to chapter 1 of doing a verbal model. And so we know that there's going to be it's going to be the amount of the number of adult tickets times the price of the tickets. I'm trying to use space wisely, times the dollar. This doesn't look sharp. Let me do this one over. So we're going to have, in terms of our verbal model, the price of adult, right, times the number of adult tickets. I'm just going to put adult plus the price of the child times, what am I doing? A number of child. And that will all equal to the total sales. Okay, so they want a model that shows the number of tickets that have been sold altogether for that season. So let's get our numbers. The price of the adult ticket is $6, and we can represent that by X. And then we have price of the child is $2.50, and we can represent that as Y. Now, if you do mix this one up with your X and Y, you're still going to get the same answers. Your graph might look different, but for this one, it doesn't matter which one's X and Y. So just keep that in mind, that if somebody else did it with your X and Y mix up, your graph will look different, but your answers can still be found. All right, so we have this. We can decide to put this in slope-intercept form, or to do this by X and Y intercepts. When it's in this format, it's easier just to do X and Y format. I mean the X and Y intercepts. So for the first one, if I change the color, it might help. I'm gonna do my X intercept as purple. So 6x plus that 250 times 0 is just going to be 0. So for my X intercept, I'm going to have 6x equals to 7,000. I'll just put X enter right here. All right, so we divide both sides by 6, and we could do long division, or we could use our calculators, which would be much faster. And this one is not going to go too evenly, but this is going to be about 1, 1, 6, 6. We can round this to a whole number. Yeah, let's just round it to a whole number. So 6, 7. Right, so that's what our X is going to be. And then our Y-intercept, different color. If we set our 6x, our X equal to 0, we're left with 250. Y equals to 7,000. And we can divide 7,000 by 2.5. And this one works out nice to 2,800. Right? And the reason why we rounded this one at this level of numbers, at the amount, the value of that number, that point 0.7, 0.66666 won't really matter. So we just rounded that one up 1 unit. All right, so now we're going to go ahead and graph this. We chose X to be the adults. So just keep in mind what X represents and Y represents the children. So we're going up in thousands because X is at 1,167 and the other one is at 2,000. We can possibly go up by maybe hundreds. That'll be 11. Can I get 11 on here? So 12 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So 1167 is going to be pretty close to 1100, about here. And then for the other one, that's 28. So let's go up by twos. They'll need 14 of them. So 1, 2, 3, 4, 5. Is that going to work? 6, 7, 8, 9, 10, 11, 12, 13, 14. So pretty high, right? So that's our other one. So if we do that, and remember your graph paper is going to come out really nice on graph paper. So if we connect those two, I'm going to have rounded answers. All right, so if we connect those two up together and we just need to answer the question now. It says then graph the model and determine three combinations of student and adult tickets to satisfy the model. So basically they're saying if we were to put these numbers here, and remember each unit here represents 1,000. So 1,000, sorry, not 1,000, 100, 100, 200, 300, 400, 500, 6, 7, 8, 9, 10, 1,100, 1,200. And so I'll just put here hundreds. So by hundreds. And this one we were going by twos, I believe. 2, 4, 6, 8. Yeah, 2. So each of these represent 200. So 200, 400, 600, 8, 10, 12, 1,400, 1,600, 1,800, 20. Was I going by hundreds? 20. Man, I've got to write in here now. That's 22. And this is why you want a lot of paper. 22, 24, 26, 2,800. Yeah, we fit it on there, but it's a little bit tight. And that's the thing with these ones. I need more screen space, but we get the deal. That's 2,800. And the combinations they want is to say, like, let's say I chose 1,600. Then you map down to 5, which is hundreds. So if I had 1,600, and remember your Y represents your child, so if I had 1,600 children tickets, then I would have 500 adults. So that's one, right? And so we're just using the concept of matching each one. So for one, I have 1,600 children tickets to about 500 adult tickets. You could choose any one because they ask you to do any three combinations. So let's say I chose, these were hundreds. Yeah, so let's say I chose 600. If I map 600 over and down, I'll say I have 900. So for every 600 child tickets sold, I would have 900 adult. And then one more, number 3. If I chose one a little bit higher, there's ones that might be a little bit crooked. So let me stick with the ones that were more even. If I chose 200, so if I sold 200 adult children tickets, they went off a bit. It's just to be just about 10, about 10 something. So if I sold 200 child tickets, remember child is your vertical. So child is vertical and X is the adults, I believe. Yeah, X is adult. All right, so if I sold 200, I would need about, what's that? 10 halfway in between, maybe 1050. So 1050 adults. Now let's go ahead and verify this one. I'm going to have to erase the side there just so that you can see the connection between them all. So once you find all that, the connection between the graphs is you can substitute those in and find out if it's true to see if it equals to 7,000. I erased the equation. Hopefully I remembered it. I think it was 6x and 2.5. So we have the price of the adult was 6x and then plus 2.5 for student or child. It's y equals to 7,000, which means if I was to pick these numbers, they should work. So let's try the first one. We have 6 times x is the adult, so 6 times 500 plus 2.5 times 1600 and see if we get 7,000. So 6 times 5. If you don't, it's mainly because my thing's a bit off. 6 times 500 is going to be 5,000. I mean 3,000 plus 2.5 times 1600 is going to give us 4,000. And 4,000 does equal to 7,000. I don't think I have to add that up anymore. So we know this one works out well, even with my graph not having graph paper. And you could do that for each one. I'm pretty sure number 2 works out well. I'll just do that on a calculator real quick. 6 times the adult ticket plus 2.5 times the student or child ticket. And I was a little bit off. That's about 6,900. So, but like I said, on graph paper, it's going to come out nice. But my first one came out nice. My third one, I know it's going to be a little bit off, but with your graph paper, it's going to match up perfect. So just make sure you use graph paper and use your ruler, and it's going to come out great.